Meter bypass capabilities allow electrical service to be maintained while a meter is being replaced or serviced. This prevents power outages during maintenance activities. Focusing on the Milbank 100 amp meter socket, the long ears on the movable lug sections are indeed part of the meter bypass feature. These ears are used for temporary connections during meter replacement or servicing. Let's examine the line ears firstly. These ears extend above the main line lugs and are used to connect a bypass cable from the source of power. Secondly, we consider the load ears. These ears extend below the main load lugs and are used to connect a bypass cable to the load side of the meter. To understand the operation, when a meter needs to be replaced or serviced, the following steps are typically taken. Firstly, the utility technician disconnects the service entrance and main breaker. Secondly, they attach bypass cables to the line and load ears. Thirdly, the meter is removed and replaced with a new or serviced one. Fourthly, the bypass cables are removed and the main lugs are reconnected. Fifthly, service is then restored through the new or repaired meter. Meter bypass capabilities offer several benefits. Firstly, continuous service. Customers do not experience a power outage during meter maintenance. Secondly, safety. Bypass cables ensure that power is not disrupted to the load side of the meter, minimizing the risk of electric shock. Thirdly, efficiency. Meter replacement and servicing can be completed more quickly and efficiently without the need to interrupt service. The line ears, extending above the main line lugs, facilitate the connection of a bypass cable from the power source, ensuring an uninterrupted power supply to the customer. The load ears, positioned below the main load lugs, are used to connect a bypass cable to the load side of the meter. This connection maintains the electrical supply to the customer's property during meter maintenance. During meter replacement or servicing, a utility technician will follow a specific procedure to utilize the bypass feature effectively. The technician will disconnect the service entrance and main breaker to ensure safety and isolate the meter. Next, they will attach bypass cables to both the line and load ears, creating a temporary electrical path around the meter. This temporary connection allows electricity to flow to the customer's property while the meter is being worked on. The meter is then removed from the socket and either a new meter is installed or the existing meter is serviced. Once the new or serviced meter is in place, the bypass cables are disconnected and the main lugs are reconnected to the meter. Finally, the service is restored through the newly installed or repaired meter, ensuring a continuous power supply to the customer. The use of meter bypass capabilities offers several key advantages. Firstly, and most importantly, it provides continuous electrical service to customers. This means that homes and businesses do not experience any power interruptions during meter maintenance, which can be particularly crucial for sensitive equipment and essential services. Secondly, meter bypass enhances safety for both utility workers and customers. By using bypass cables, the risk of electric shock is minimized, as power is not disrupted to the load side of the meter during the maintenance process. Thirdly, it significantly improves the efficiency of meter replacement and servicing. Without the need to interrupt service, technicians can complete their work more quickly and effectively, reducing downtime and minimizing inconvenience to customers. In summary, meter bypass capabilities are a valuable feature in modern meter sockets. They enable utilities to perform necessary maintenance and replacements without disrupting electrical service to customers. The use of line and load ears for temporary connections, along with a well-defined operational procedure, ensures a safe, efficient, and customer-friendly approach to meter maintenance.